Hi everyone, myself Satvik, roll number 20951A05G4, branch CSC, section C. The topic which I got for concept video for the subject operating systems is buses. Introduction. The electrically conducting path along which data is transmitted inside any digital electronic device. A computer bus consists of a set of parallel conductors, which may be conventional wires, copper tracks on a printed circuit board, or microscopic aluminum trials on the surface of a silicon chip. Each wire carries just one bit, so the number of wires determines the largest data word the bus can transmit. A bus with 8 wires can only transmit 8 bit of data, and hence defines the device as an 8-bit device. The bus is a communication channel. The characteristics of a bus is shared transmission media. The limitation of a bus is only one transmission at a time. Bus used to communicate between the major components of a computer is known as a system bus. Diagrams of a bus connecting with devices. Here you can see three major parts. One is CPU, the central processing unit, where all the calculations, all the operations are performed. Other is a memory subsystem, where you can store all the data which you need. The third one is IO subsystem, which consists of IO devices. Here IO means input or output devices. You can see clearly that there are three lines or three buses in the diagram. One is address bus, another is data bus, and another one is control bus. In our coming slides, we will go in detail about these buses in separate. So first, let us dive deep into the topic. What is an address bus? An address bus is a computer-based bus architecture used to transfer data between devices that are identified by the hardware address of the physical memory. The physical address, which is stored in the form of a binary numbers to enable the database to access memory storage. The address bus is used by the CPU or direct memory access DMA enable device to locate the physical address to communicate, read or write commands. All address buses are read and written by the CPU or DMA in the form of bits. An address bus is part of the system bus architecture, which was developed to decrease costs and enhance modular integration. However, most modern computers use a variety of individual buses for specific tasks. An address bus is measured by the amount of memory a system can retrieve. A system with a 32-byte address bus can address 4 gigabytes of memory space. However, computers using a 64-bit address bus with a supporting operating system has 16x bytes of memory locations, which is virtually unlimited. And the main point is the address bus is unidirectional. What is a data bus? A data bus is a system within a computer or a device consisting of a connector or set of wires that provide transportation for data. A data bus can transfer data to and from the memory of a computer or into or out of the central processing unit that acts as the device engine. A data bus can also transfer information between two computers. The speed at which information is exchanged between components is regulated by the bus controller. Information coming from the CPU, for example, will always travel at a much higher speed than the data coming from the other components. However, in a computer, everything must travel at the same speed, and bus controllers serve this purpose. Earlier, first generation data buses had no controller and consisted of simple bundles of wires that connected computer memory to the various peripheral devices. A data bus can operate as a parallel or serial bus depending on how the data is carried. A parallel bus is used in more complex connection that must require more than one bit at a time. Common examples include peripherally connected interconnect express and small computer system interface connections. Data is carried on many wires simultaneously. What is a control bus? A control bus is a computer bus that is used by the CPU to communicate with devices that are contained within the computer. This occurs through physical connections such as cables or printed circuits. The CPU transmits a variety of control signals to components and devices to transmit control signals to the computer using the control bus. One of the main objectives of a bus is to minimize the lines that are needed for communication. An individual bus permits communication between devices using one data channel. The control bus is bidirectional and assists the CPU in synchronizing control signals to internal devices and external components. It is comprised of interrupt lines, byte enables lines, read or write signals, and status lines. Communication between the CPU and control bus is necessary for running a proficient and functional system. Without the control bus, the CPU cannot determine whether the system is receiving or sending data. It is the control bus that regulates which direction we need to perform read information needs to go. The control bus contains a control line and the instructions and a control line for reading instructions. When the CPU writes something on the main memory, it transmits a signal to the right command line. The CPU also, when it wants to read it, the control line gives read command line when it needs to read. So the read and write controls are controlled by the control bus. Advantages of buses: versatility. New devices can be added easily. Peripherals can be moved between computer systems that use the same bus standard. Low cost. A single set of wire is shared in multiple ways. It costs less. It also manages complexity by partitioning the design. Have so the disadvantages of buses are: it creates a communicational bottleneck. The bandwidth of the bus can limit the maximum input-output throughput. The maximum bus speed is largely limited by, first thing, the length of the bus. If the length of the bus is small, there will be more speed. If the length of the bus is if the length of the wire is large, there will be the speed will be less. The number of devices on the bus, like if there are more devices connected to a single bus, then the time taken or the reaction time will be more. If less devices are connected, the reaction time will be less. The need to support a range of devices with widely varying latencies, widely varying data transfer rates. For example, the buses need to manage a CPU which is high speed, a memory which is low speed. So this this will cause a disadvantages of buses in speed. With this, I hope that you have gained some knowledge about this topic. I would like to take leave from you. Thank you.